Hey guys, it's Casey, and today we're going to be talking about IUPAC naming in branched hydrocarbons. This is the first video I'm making about naming organic compounds. We're going to start off simple, which is just hydrocarbons, just carbon and just hydrogen. It does get a bit more complicated, and the rules do eventually change. So we're going to get right into it. I have, as you see on the left, the condensed structural formula for various compounds, and we can go down. I have three of them we're going to look at, and on the right is the bond line representation. I'm still doing the condensed. It kind of helps just until we get the hang of everything, then we can move over to strictly bond line. But if it helps you guys learn better, that's the purpose of these videos. I will continue making them in the condensed version as well, along with the bond line. So for rules of naming, the first thing you're going to want to do is locate the longest carbon chain. So the longest chain of consecutive carbons. The first one we can look at right here, we can see that we have a little branch off here. We have a 5 carbon chain, which is our longest carbon chain. We can see 1, 2, 3, 4, 5, and we have a branch right here. Just in case you guys didn't pick up in the last videos, a little branch like this is referred to as a methyl group. So that's just one thing we're going to take into consideration. It does get more complicated, and we are going to move into more complicated branches in a later video. Like if it extended over to 2 different carbons, then we'll call it an ethyl group. And there's a whole different way to name it, and it does follow a specific pattern. So as we said, there is 5 carbons, which is the longest carbon chain. Now, once you locate the longest carbon chain, you're going to want to number it from 1 to whatever amount of carbons you have in the order that gives the lowest number to the first branch. So you don't care how much branches you have, it's the first branch you want to give the lowest number, and you need to start from the end. So I can't just start 1 right over here to give it the lowest number of the branch. I need to start all the way at the end, right over here. 1, 2, 3, 4, and 5. If I started at this end, once I get to the branch, which is over here, we'll circle the branch just so we don't get confused. We would get, we'd have number 4. It'd be 1, 2, 3, and 4, which is not the lowest number because 2 is a lower number than 4. So that's the essential logic behind it. Now, if you're wondering why I chose to number this as number 1 and choose this as a branch, it works out the same way. Even if I counted 1 over here and this would be the branch, it works out to the same thing. Those are identical ways of looking at it. If we were going to look at the numbering on the bond line representation, we'll do it in blue. We'd have 1, 2, 3, 4, and 5. And having our branch would still be on the second carbon. Now you're going to want to find the name associated to that carbon chain. Remember we looked at the straight chain alkanes a couple videos ago? I have the same little graph over here. We have 5 carbons in a row, and that corresponds to pentane. So we are going to need the ending of pentane is going to be in our overall name, and we're going to add on a little bit of an indicator to tell the reader what branches or what substituents are also on that pentane and where they are. So we know that it's going to end with the word pentane, but what comes before? That's where we look at our substituents. We have a methyl group at carbon number 2. So we are going to write 2 hyphen methyl pentane plus that. So altogether it would turn out to look like 2 hyphen methyl pentane, all one word. So as you can see here, we have the longest carbon chain, we have the substituent that is attached, and we have the carbon using the lowest numbering system at where that substituent is attached to. We'll do a couple more so you can see exactly the importance of following the procedure, those specific rules. Like number here, we have the same one, but we have 2 different substituents. We are going to add an extra step later on in the naming. So we're going to do like we did before, assigning the lowest number to the first substituent. So numbering from this end would not give you it because you'd reach 3 by the time you got to the first branch. So we're going to number from the other end. And as you can see, we still have a 5 carbon longest chain. So 1, 2, 3, 4, 5. And now you see we have a substituent on carbon number 2, and we have a substituent on carbon number 3, and those once again are both methyl groups. So because we have 5 carbons as our longest carbon chain, we are going to use the ending pentane. But now we have 2 different methyls. So how are we going to name this? We are going to indicate the different carbons that both of them are attached to by separating them with a comma. So 2, 3, so that indicates we have methyl groups on 2 and 3, hyphen. Now we can't just say methyl because we have 2 methyls. We need to use the classic Greek prefixes. So di indicates 2, methyl plus pentane. So overall our name would be 2, 3 slash or hyphen dimethyl pentane. This immediately tells our reader that there is a 2 methyl groups, and they're located on 2 and 3 numbered carbons on a pentane 5 carbon chain, and they can automatically draw out the diagram like this. You can see we number 1, 2, 3, 4, 5. Methyl group number 1 on carbon number 2, and methyl group number 2 on carbon number 3. There's 2 methyls, that makes dimethyl. Now that's the basic rules you really need to understand. We'll do one last one just so we make sure everybody understands the same process. So starting off, where is our longest carbon chain? We count 1, 2, 3, 4, 5 carbons. Now which way do we number this? We see that we number 1, 2, we get already 2 is the lowest number on one of our branches, and we number from this way 1, 2. Doesn't matter in this case. No, it doesn't. It's symmetrical. No matter which way you number it, you'll always get the same lowest numbers, or locants as they're called, on the branches. So in a case like this, you don't need to worry about it, but you need to make sure that you're clear on when you should be numbering in a specific direction and when it doesn't matter. So we can number 1, 2, 3, 4, 5. Once again, we have 5 carbons, so we're going to have that pentane ending. And remember, if you need to look at this graph, I have a this chart that I made here. It tells you all the endings that you can possibly have, up to 20. Obviously, it goes on and there's specific patterns, but in most organic chemistry classes, you will not need to know past 20. The third video I put out in the series goes over that list in depth if you need to go take a look at it. But for now, we're just going to be looking at pentane and some of the, maybe go up to 10 in the series. So what else do we have? We have a methyl group on the 2nd carbon, a methyl group on the 3rd carbon, and a methyl group on the 4th carbon. So I like the same pattern. We're going to separate them from commas. 2, 3, 4, hyphen. Now we need to have the Greek prefix that indicates 3, and that is tri. Now we're going to indicate what the group is. It's a methyl group, methyl. Now we're going to indicate our longest carbon chain, which is pentane. And right there, we just named this compound 2,3,4 trimethyl pentane. And we can look at the bond line 1, 2, 3, 4, 5. Methyl group on the 2, methyl group on the 3, methyl group on the 4. Longest carbon chain of 5 carbons. It's a pentane parent compound. So that's the basic introduction to naming hydrocarbons. It does get a lot more complicated. There are a lot more rules when you start getting OH groups in there. They get priority and you have to number it all differently. So I'm going to continue on. I'm going to try to dissect it all into different parts just so nobody gets confused. But this is the first thing you'll normally be introduced to in an organic chemistry class in terms of naming. So if you have any questions, please leave a comment below and I'll answer you as soon as possible. Thank you very much for watching and have a good day.